Awesome. Good afternoon, everyone. Thanks for joining. I know this is late in the day. Hopefully, you saved some of the energy for our session. Just to make sure you're in the right session, this is XNT311, Go Codeless and Replatform Windows Applications with EKS. My name is Samuel Barufi. I am a Principal Solutions Architect here with AWS, covering global financial services. And I have the pleasure to have with me on stage Jared. Jared is a Solutions Architect for Microsoft Workloads. And I also have the pleasure to have with me on stage Sri. Sri is a Senior Director, Head of DevOps for Moody's. And what we're going to cover today is we're going to talk about how you, if you are running Windows applications, and I'm going to ask you a question in a moment, how can you move your existing Windows applications, potentially some of the legacy Windows applications, into containers without changing any of the code? And you're going to share some of the best practice on how to do that. We have Sri telling the story from Moody's on how a large financial institution have gone through that journey and some of the challenges and some of the things that they've learned throughout the way. So before I get started, can I maybe get some, I can barely see you, but can I get some hands up if you are currently running Windows applications? Okay, I see a lot of people, right? You're in the right place. How many of those that are running Windows applications are running on containers? Okay, that's what I expected. Very few of you. And for the few of you that raise your hand, how many of you are running on EKS? I can't see anyone. So good. Hopefully, I see one or two person. So you are in the right place if you want to learn how you can do that and some of the best practice that both AWS have put in place for you to actually run those workloads. Before we get very technically, which we will in a moment, we just want to share some of the current state of technology, right? It's known that a lot of Windows applications into big institutions like financial services have become legacy, but it's important to highlight now that not all Windows applications are legacy, right? So there is a differentiator, and not all Windows applications are legacy. Jared will mention in his part of the presentation that we have very cutting-edge gaming customers that are building Windows applications on containers on top of EKS, and it's very new application, so it's not legacy. But we do see a trend that a lot of customers have legacy applications on Windows. And those customers face a lot of challenges. What we are presenting here are kind of two different categories of challenges, but that they connect very well together. Some of those challenges are more business challenges. Other challenges are technical challenges. So let's start with the business challenges. As every company in the world wants to progress and innovate, there is more and more pressure to innovate with velocity. If you have an application that is potentially using old technology or hard code base to maintain, that is a challenge, right? Not only a technical challenge, but also a business challenge. As you have applications that are running unsupported versions of potentially .NET framework or some sort of third-party vendors that you have coded 20, 30 years ago, it becomes very challenging to actually maintain, and the cost will increase. Jared and Sri are going to talk on how normally you used to run Windows applications. So you have like maybe a monolithic application, and that monolithic application will be deploying a virtual machine on our server, and that becomes very hard to scale that application. So at a lot of times, you have these applications that haven't received enough love throughout the time, but you have the need to scale this application, right? So your business might say, I have sold 500 new users for this application, and then you look at your monolithic running on a very small virtual machine, and you'll be like, well, what can I do other than scaling vertically, right? And how do I maintain that into a way that is cost effective? So that is one of the challenges we have. And I think the last one on the business side, I don't think this is spoken enough, but as newer technologies, and we all know generative AI and other things have kind of dominated the space in the last couple of years, but as new technology becomes like the new normal, less and less people are actually skilled to maintain these legacy applications. And you still are making money with those legacy applications, you're still making money with them, and you don't have enough people to support them. And all those challenges will connect very well on the technical challenges. So the first one is These applications that are very old normally will actually concentrate a lot of technical debt. Maybe you don't have teams supporting the code anymore. You just have that application, that code base that is running, and nobody knows how that application works, right? So people have this idea that the less they touch, the better, which it can be a challenge. As third-party packages or even .NET frameworks or non-.NET frameworks on Windows become outdated, you have security issues. How do you update those, right? And that is an important challenge that you need to consider as part of your organization. And the last shoe is you want to utilize, we are in the era of the cloud, right? You want to utilize the best tool for the job, right? You want, the whole idea of cloud, one of the main benefits is elasticity, right? If you have this application that is really hard to move and you can only scale vertically on virtual machines, that becomes a challenge to actually scale on demand. If you have a peak, maybe your application has a peak during the week, and then during the week you want to scale down, it becomes very challenging to do that. And let's say you have this monolithic application, and with this monolithic application, you now want to start to decouple that and integrate it with AWS services. Maybe you want to run some serverless functions. Maybe you want to run some containers. If you have this big monolithic, it becomes very challenging, right? So with all that in mind, what we want to talk today is how can you modernize your Windows applications and replatform these existing Windows applications that are potentially running maybe on EC2, maybe or even on-premise. How can you actually move into cloud-native containers? The idea here, the title says codeless, and I just want to explain what it means, codeless, right? Codeless is the very simple idea that you are not going to need to change your application code to replatform on top of containers. There are things you need to do in order to have best practice, both on the operational, security, and performance, that Jared is really going to go in depth in a moment on how you do that on top of EKS. And the idea here is once you containerize those Windows applications, you can run that on top of orchestrators on AWS. We are going to focus today on EKS. Just Moody's have chosen EKS as their main orchestration platform, and Sri is going to go in depth about that. But it could be ECS, it could be Fargate as well. The best practice might differ. Today, we're going to talk mostly about EKS. One of the main benefits for you to choose this centralization of orchestration, we see customers from different sizes already adopt a centralization of orchestration. So maybe they decided Kubernetes is their orchestration of choice, right? You don't want to have this kind of specific way of running just the Windows applications on the side, because now you have potentially, your DevOps team, your platform team that is really focusing on the innovation on one side, and you kind of keep the Windows applications on the side. This whole idea is that you bring Windows applications into EKS, into your orchestration for containers, and then you can manage and use the best practice, the pipelines that you have in place, using the common API of Kubernetes. And by doing that, you can share architecture patterns, you can maximize resiliency by using different scalability, different approaches that Kubernetes kind of give out for you, as well as EKS. So one of the things that we see at AWS for Windows modernizations, we see kind of 3 different steps. It doesn't mean that you need to follow each of these steps sequentially. We see a lot of customers following that sequentially, right? You can go to the last one and modernize using serverless. But what we normally see is you have maybe Windows applications running on-premise on your data centers, and you want to move that application to the cloud. Right? So the first thing you do is what we normally call lift and shift. You get your application, you just create an EC2 image, you put your application on that EC2, and then you move into that. If you have, for example, a SQL Server, you might be using just SQL Server on EC2. You might not even want to touch RDS SQL Server, right? So that is kind of the first path, right? Which is relocate and rehost. Sometimes is also mentioned as lift and shift. We are not going to talk about that today because we believe a lot of customers have already gone through that journey, or maybe they will be going soon. What we want to focus is how can you replatform. So you have this application, you don't want to invest a lot of resources, engineering time to actually modernize that application. Potentially it's a legacy application, but you do want to run on cloud-native technologies. So the idea of replatform is you containerize their Windows applications. There is a lot of best practice that you need to keep in mind when doing that. Once you do that, then you can choose your orchestration of choice. You can run on ECS. You can run ECS with EC2, ECS with Fargate, or like we are going to be focusing today, you can run on EKS and EC2 Windows nodes. But that is not the end, right? We see a lot of customers taking further, which we're not going to talk about that today, but if you have already containerized your Windows applications, and your Windows application are legacy and you really want to modernize, there are a lot of things that AWS support, right? You can move from a .NET framework to a .NET Core, right? So you can run that on even Lambda functions. So you can have a completely event-driven application or even microservice application by doing the modernization. And that's what we call refactor and rewrite. So just to kind of do a nice animation, you're moving from virtual machines into containers. So that's what you're going to focus for the majority of the talk. So I will pass it over to Sri. Sri is going to go and is going to talk about their journey from Moody's, about how they have actually modernized legacy Windows applications using containers on top of EKS. Over to you, Sri.
Thank you, Sam. Hi, everybody. This is Sri from Moody's. I manage cloud infrastructure for banking OU in Moody's. And at Moody's, we have two major entities, Moody's, which is Moody's Analytics and Moody's Ratings. Moody's is in this business for more than 100 years. So today, I'm going to share my experience on converting applications from data centers to AWS, especially EKS, like Sam mentioned, without any code change. So the story started about 5 years back. We are the very first implementers of Windows EKS, converting applications from data center to cloud. So it was quite a journey, a lot of challenges, learning, all that. So including AWS team and our team, we learned it together, but definitely it was a successful story. And after 5 years, if I look back, I have almost all the applications converted from data center and migrate running in EKS now successfully. So out of these many applications, I picked up today about 4 applications, which are our flagship applications. They're running in Moody's for more than 15 years, and they're all in the .NET world. So this is Risk Frontier Deal Analyzer, which is a credit portfolio risk management solution. There is another 3 products, RiskCalc and CMM, ZM. They are all in the same portfolio. Additionally, they're all developed on Windows .NET 4.8 framework. They're still running on it. We did not make any changes, but still running on EKS. So they're hosted by Moody's in our data centers. This is pre-EKS. And then usually they run either on an application server and database, and then maybe are multiple app servers and multiple database servers. We throw some calculation servers in the mix based on the client requirements and workloads and all that. So how did we handle this migrating into cloud? And also, what was the drive for modernization? So when we look back at all these four plus applications, each of these applications will cost around more than $5 million to refactor or re-architect in a different language or in an operating system. And then cost of the supporting the existing application while we are doing this refactoring also is very high. And at the same time, we have to pay for hardware and software licenses, which is also unmanageable sometimes. Like I mentioned, based on client requirements, we throw additional calculation engines in the mix. That's where we have to add more servers or virtual machines. And then these instances are used. Servers are used and left behind, sometimes unused. So we have to pay for them as well. And then while this whole new application, if we have to re-architect, and then if it has to go live, it takes some time to market and go into and just start selling. So it's a time also. So based on all these situations, we decided if there is anything that we can use without doing a lot of this effort, we can run these applications in a new technology. So that's where we found EKS. We were definitely waiting for that when they announced almost about 5 years back in the same reInvent in 2019. So then that is when we adopted. So after all these 5 years, successfully migrated all these applications into EKS and running, I collected these things as like some benefits of EKS, essentially running Windows applications on EKS. So speed to market. So like Sam mentioned, the monolithic applications, right? So all these applications were running in a data center on IaaS as a monolithic application. So if there is some new feature we have to release, that's quite a wait. We have to go through all the non-prod and then production. For every single small change, it causes a downtime, and it's an effort. So now we converted all this into the EKS. That means like containerized all these applications. We modified them into lightweight APIs. So it's now very easy. You can simply change whatever the changes you want to make and then push to production, and you are already in live. So that's definitely a big achievement. And modernization, so anything on the containerization, EKS platform, and auto-scaling, cloud, all these buzzwords definitely was like market industry standard modern technologies. I don't think there is any necessity for us to look back and see there is any refactoring needed anytime soon. We can definitely survive with this for few years in future. So pay as you go. This is for sure. As you know, I'm just paying for whatever we are using. It's like I said previously, I'm not paying for any unused resources. There is no limit. I can just simply add as many resources as need. And then operational easiness. This is something I'm very much interested as an operations person. There was a lot of challenges in data center. I had to hire people in system administration, networking, managing, and all that. At least for these 4 applications, I had at least 15 people to manage all these applications. But now on the cloud, on EKS, we are very big Terraform shop and a lot of other automation tools. So with all these automations and no manual intervention, no errors, my resources came down to 3. I can just manage all these applications with only 3 people with a lot of easiness. And then I don't have to deal with all that standard operations. And on top of that, very importantly, I would like to say about patching. So we don't patch these Windows instances anymore. It doesn't mean we don't patch at all. We patch, but it's a different way. So the way we patch is like we rehydrate these instances. So basically, we take every new AMI available in AWS, they release on a frequency. So we pick up that and then bake our own golden army. We add the tools and bells and whistles, whatever is needed into that AMI, and that becomes Moody's golden AMI. We take that AMI and then rehydrate these EKS clusters. So that's basically reset everything to brand new instance. That takes away a lot of other security holes, issues, and all that as well. So basically, if it is an EKS, we just change the launch template, and with the new AMI, it picks up the new image. That's one big advantage for me as an operations person. Stability and reliability. It's basically on AWS. So as you know, all these instances are spent in different AZs. AZs are geographically separate, and then AWS manages all these AZs with its own backup power, cooling, and all that, whatever the features they can add. So it's definitely reliable than any other data center we can compare. And secure and scalable. AWS has a lot of security policies implemented there, like you have Amazon Inspector is there, and Guard Duty, a lot of other stuff for all the services. And then they have many protocols implemented for encryption and all that. So if you look at S3 at rest it is encrypted, and in transit data is encrypted and all that. So scalability, for scalability, it's basically all EC2s and the nodes of the clusters and all that, and then load balancers, all that can be scaled to whatever the need we have. Single sign-on, this is another feature that proprietary to us. Essentially, we were already in AWS. Many of other applications are already running. So bringing these other leftover, the Windows applications made it easy for us to integrate it into our existing single sign-on, so that it was a seamless integration. And disaster recovery, so like I said, we are a Terraform shop, so I have a production blueprint that is produced and running my production. So when I had to build the disaster recovery in another region, we just applied the same blueprint, and there is a warm standby disaster recovery ready for me in a different region. So these are all main advantages being in AWS and on EKS on Windows. And I also want to share some challenges. It's not just only benefits, right? So those challenges may not be specifically for EKS, but maybe because I have Linux and Windows, a mix of a lot of these clusters, I'm just basically sharing my experience comparing Linux and Windows. So this can be like a comparison between Linux and Windows. So the complexity is basically setting up the Windows cluster and Windows nodes, attaching the nodes and all that may be a little bit complex compared to Linux. That is because of the additional steps needed for configuration and management. And the cost. Cost is not about EKS, but it's again about Windows, because it's the nature of the Windows. As you know that Linux costs less and Windows costs more. So that would probably increase your cost of EKS on Windows. And then feature parity. So this is basically again compared to Linux and Windows. So the features of Linux is always advanced than Windows. When you see, you might be missing a few features in Windows clusters, but that should not be stopping you using Windows. And resource overhead. Resource overhead is again on Windows side. So as all of you know, Windows utilizes a lot of resources, CPU, memory, and all that. So that's where you probably might need to provision larger instances, which would probably cost a little bit more than Linux as well. Community and ecosystem. So Kubernetes community historically focused on Linux. And again, the features, like I said, may be a little bit behind Linux, but they are catching up. Boot up time. So boot up time is, you might have seen the EC2 instances usually takes Windows instances a little bit longer than Linux. And also if you add any Docker images into the AMIs or anything, then that will add a little bit more to the boot up time. So Jared these are all the challenges, but Jared will explain whether we need to compare Windows and Linux or not, and how we can overcome and work around all these challenges and make sure the cluster runs same as Linux. In the next few slides, Jared will cover that. So this is my current landscape. As I speak, we have more than 200 EKS clusters with more than 400 Windows instances. And there is FSX, the file system used. At this moment, it has more than 25 terabytes. And a lot of RDS SQL Server instances, which has more than 1,000 databases. And then Amazon Elastic Cache with more than 1,000 databases. Not only these services, but we use many services that seamlessly can be integrated with the EKS. And that's the beauty of being in AWS. So you can basically use all the services managed by AWS. So this is now a high-level architecture of our infrastructure, how it's being run and how we implemented it and migrated. I'll just go through it quickly. This is definitely high level. There are many pieces to it. So the functionality-wise, like I mentioned, these applications are very heavy data intense. Like all this it basically runs a lot of calculations behind the scene. It takes hours to finish sometimes these calculations. So the client uploads the data, and then the data and the request is received by the front layer there on the API layer. So there is a job manager sitting in the API layer that receives the request, and then it basically input the data into the database and also save this data, the files uploaded by client into the FSX, and then schedules a job. It put it in the RabbitMQ. So basically, RabbitMQ, it schedules jobs in the job execution layer based on the workload and the size of the data. And then during the processing of these jobs, the events and job status and all that stuff is written into the event store. So there is a job monitoring API sitting in the same API layer, and that basically gets the data from event store and reports it back to the client as it progresses. So that's about just the functionality. But the architecture-wise, so in EKS, all these verticals, what you guys are seeing there is each layer is a node group, a managed node group with different sizes and all that. So these managed node groups are, we have to manage explicitly with autoscalers and the sizes and resource limits and all that. You define it and you manage all of it. But recently, we implemented Carpenter. Carpenter is an open source project, and hopefully it will be a managed service soon, right? So, but we just implemented that Carpenter. Carpenter is nothing but a EKS node lifecycle management tool. It basically looks at the unscheduled jobs resource limits, and then schedules the jobs or like the pods based on the size and whatever it can, and the time and the need. So it does everything automatically, right? So basically it's now, instead of managed node groups, we have node pools and node classes. So a node class is nothing but a definition of what you want to define there. Where do you want to provision this in VPC, in which security group, and which IAM role it has to use, and which AMI it has to use. All that you will define in the node class. Node pool is where you will define the sizes. You want to use a M4 X large, 2X large, 4X large, or whatever is the maximum, and then the lower side, you define all that. And you can also set limits for 1,000 GB of your RAM and 1,000 CPU, or what, that's your upper limits. Otherwise, it will go kill the cluster, right? So there are the limits set in the node pool as well. So now once that is applied, the Carpenter will automatically scale up and scale down the nodes. It's definitely a very good improvement for the EKS. If someone wants to try it, I would encourage that. It's another big thing is it saves cost a lot. You're not really, you're basically shutting down the things that you don't need it when you really don't need it. And then the FSX is something that we used to mount it on the EKS nodes, but these days we are mounting directly onto the pods, which is mounted as a persistent volume and a persistent claim. So far we talked about the architecture and functionality, but the session, the topic is about the codeless, without code change, the migration, right? So where did we do that? How did we do that? So this is running fine in the cloud, but how did I bring the whole application into this model, right? So in application build and deployment, say I have artifacts that are built and compiled from this .NET 4.8 framework, and which were directly deployed on a virtual machine or a server in a data center on an IaaS running fine. But how do I convert that? We really didn't do anything. Did not change a single line of the code. We took the artifacts and basically segregated this monolithic application. If we can make that as small APIs, just only the segregation of the binaries, and package that into different Docker images. So every Docker image has an entry point. In the entry point, we call this bootstrap script a PowerShell script. That PowerShell script in turn calls other scripts internally, which basically what it does is it prepares the environment for the Docker to run. It loads all the variables and as environment variables. So it reads this data from EKS config map or EKS secrets or AWS secret manager, various sources, and then reads all the data and basically token replace the values that are already created as tokens or properties in this container and set this as an environment variable. So the Docker, when it starts running, it reads the data from the environment variables. And these scripts also prepares the app.config or web.config, whatever the configuration files needed IIS to run, and then also it creates websites, app pools, everything needed. These are all like bootstrap. So it prepares the environment, and the container starts with all the necessary data. Sometimes the certificates are also installed on IIS from legacy applications like REST API and all. So we store the certificates in S3, pull them on the fly, and install it on IIS as well. This is all like pre-built before the runtime. So the containers run as usual, like running on an EC2 instance. So that's like in a nutshell, high level, the architecture, how we package the applications and running in a EKS in a new architecture. Right? So other than that, what else we achieved? Cost performance improvement. Cost is always an important thing. Right? So compared to the data center world, we definitely reduced 45% of the cost migrating into EKS. And then Carpenter recently adopted. Definitely it's doing a lot of optimization, cost optimization, and then we are now able to use the Spot instances as well on that. That's an additional feature. And then node launch time. Like I mentioned, node launch time is always longer than Linux. It was about 15 minutes to 6 minutes. It came down to 6 minutes. So this we could make it by adding the images that we need to run on these instances in the AMI itself. And there is another feature called fast launch AMI that also we enabled on Windows. So that will definitely increase the launching time. And then container launch also is reduced. Basically, the Windows containers are much larger than Linux. Even in the Windows, there are layers. The layers are downloaded during the runtime. So instead of downloading them, we can download all the layers and pre-build the images. So that's how we can improve the performance as well. Jared will explain how we can get through these complexities and then make it more efficient and run effectively in next slides. So that's all I have for now. Thanks for listening. If you guys have any questions, we'll take it after the session. Over to you, Jared.
Awesome. Thank you, Sri. So let's explore some of the reasons why you'd want to run Windows applications and containers on Amazon EKS. In the old days, it was common and often recommended that you run one application per server so that the apps and their dependencies didn't conflict with each other. But containers, by definition, are isolated. So this allows us to run more apps per server, which come with some huge benefits in terms of increased compute and storage efficiencies. Since a full operating system is not required to run each app, we get storage optimization benefits for running the same number of apps. And since we're not deploying the full operating system, we're reducing the number of Windows licenses and therefore save money. Each version of Windows Server gets about 10 years of support from Microsoft before it's deemed to be end of life, and you should upgrade. But it's not always easy to upgrade, and things change between versions of Windows, and you might experience compatibility issues. But by containerizing the app and its dependencies, of which some may be legacy and incompatible with newer versions of Windows, It makes it really fast and easy to test your apps on newer versions of Windows. And the quicker you can test your apps, hopefully you'll avoid those expensive end-of-support contracts. Containers are not a new technology, and they're a proven solution within many of our customers' businesses. By leveraging the in-house expertise you probably already have, you can really maximize your DevOps and platform engineering investments that you've made. And Kubernetes, as Sri's shown us, is a key component of this. And he's shown how Amazon EKS has really helped Moody's with their journey to using Amazon EKS and Windows containers. It's a misconception that Windows containers should only be used for running applications that use .NET Framework. Any Windows-compatible framework can be used. And we often see customers running commercial off-the-shelf or COTS applications inside Windows containers. And as Sam pointed out earlier, we have gaming customers that use Windows containers to perform builds for PC platforms and gaming servers. As the title of this session suggests, we want to take a codeless approach to containerizing our Windows apps. We want to modernize the platform, but not necessarily refactor the app because that costs time and money. The modernization journey is not about moving to microservices and using a service mesh, but rather it's a replatforming strategy to optimize the underlying platform. Windows containers reduce the maintenance overhead by opening up the possibilities to use serverless technologies such as AWS Fargate. Windows and Linux have different use cases, but in terms of manageability, they are equal. They both need to be patched, they both need to be maintained, and eventually each version of the operating system will go end of life, and you should upgrade for support and security reasons. So let's explore some of the strategies we can use to improve the experience of running Windows containers on AWS. To run a Windows container on Amazon EKS, the underlying host needs to be running Windows Server, of course. AWS provides an Amazon EKS optimized Windows Server Amazon Machine Image, or AMI, that makes this really easy. So let's take a look at how that AMI works. We have the kubelet, which facilitates communication between the worker nodes and the EKS control plane. And we have the kube proxy, which acts as a network proxy for managing the network rules for routing traffic within the cluster. The AWS IAM authenticator for Kubernetes relieves the need to manage a separate set of credentials for Kubernetes access by leveraging AWS IAM roles instead. The Container Credential Guard, or CCG plugin, may be unfamiliar to you if you haven't run Windows containers on Amazon EKS before. What it does is that it enables domainless Windows authentication for your apps. And by this, we mean the worker nodes within the cluster don't need to be joined to an Active Directory domain for Windows Auth to work. What the CCG plugin does is that it retrieves credentials from AWS Secrets Manager or AWS Systems Manager parameter store, and then it makes a call to Active Directory to receive a group managed service account, or GMSA identity, which it then passes to the pod to use. Containerd is the included runtime now within the EKS optimized AMI, and this became the standard container runtime for EKS in version 1.24. What it does is that it exposes a REST interface so that CLI tools can interact with the container runtime. The container runtime interacts directly with the low-level kernel APIs to create process isolation like job objects and object namespaces. Kernel access is allowed in Linux because it is native functionality within the operating system. That's the way it was designed from the ground up. But Microsoft realized that the community was not going to create and maintain two different runtimes, one for Linux and one for Windows. So what they did was they developed the host compute service, or HCS layer, which is an additional layer on top, and it exposes the low-level kernel APIs through an API written in C. So now, as a container runtime developer, you need to build the runtime in order to talk to that C API. And to be honest, that's not that easy. So Microsoft developed a wrapper on top of the HCS that provides two options for calling it from higher level languages. HCS shim is the most commonly used one, and it's written in Go. And we have .NET Compute Virtualization as well, written in C#. So it's easier for us to understand these high-level languages, and then the wrapper talks to the C API in the HCS layer. The HCS layer itself handles all those low-level kernel tasks I was talking about. And just to give a very brief explanation of the difference in Linux and Windows, in Linux you have control groups or C groups. Windows uses job objects instead. Linux has namespaces. Windows has object namespaces. So the HCS layer handles the orchestration process of creation and isolation through these two components, and then it passes the information back to the runtime so that the container can be created. We often hear that Windows containers take a long time to launch versus their Linux counterparts, but there are some caching strategies we can use to improve this. We see here in the image that it takes about 4 minutes to download and extract the intermediate layers of a Windows container image. But how do we solve this problem? Well, to resolve it, we need to understand the root cause first. So as mentioned previously, AWS provides the Amazon EKS optimized Windows Server AMIs, as well as ECS optimized AMIs and ones for AWS Fargate. Now, these optimized AMIs include the base images for Windows Server Core and Windows Nano Server. So what this means is that approximately about 40% of the Windows container image is already extracted on the host's disk as part of the AMI. The most common use case for Windows containers are running .NET Framework applications, and this obviously requires the .NET Framework runtime to be installed. So now you need to bake in that .NET Framework runtime into your container. But what if your app is running on relying on ASP.NET? Well, now you need both, perhaps even the application layers as well. So what you end up with is a Windows container image that's perhaps 4 or 5 gigabytes in size, plus whatever your application is consuming on top of that. It's not uncommon to see Windows container images that might be 7 or 8 or even more gigabytes in size, and it's really large when we compare them to Linux containers that might be, say, 200 megabytes. If we're not using the right caching strategy, the first Windows container on the host will need to pull all those layers down, and the most expensive part of that process in terms of time is the extraction. So with regards to Amazon EKS, it's container D that has to do the heavy lifting of extracting all those layers, and it can take a long time if the image is large. We can speed up the Windows container startup time by leveraging Amazon EC2 Image Builder to implement a caching strategy. EC2 Image Builder will create a pipeline to build custom AMIs for EKS and ECS. It's common to see Microsoft release scheduled updates on the second Tuesday of every month, or what's become known as Patch Tuesday, and they also release unscheduled critical updates, and you probably want to include these in your custom AMI. You'll also want to include the layers that we spoke about earlier that make the application run. And if your application is considered to be legacy within your business, and perhaps it's not being updated all that often by your developers, you might even want to include it in the container image to help the startup time even further. So what happens is at the end of the pipeline, you end up with an Amazon a custom EKS or ECS optimized AMI with the pre-cache layers we spoke about available on the host disk already. You can enable fast launch to improve the EC2 instance's startup time, and we'll dive into that a bit further on in the presentation. EC2 Image Builder is able to update the EC2 launch template so that when new instances are provisioned, they use the new version of the AMI, and then customers can manage the draining of the pods running on instances running the old AMI and decommission those instances. Let's look at a real-world improvement that this caching strategy makes. So this is an example of a Windows container running an ASP.NET application, but in this example, we're not using a custom AMI. In the screenshot, it shows that EKS took 7 minutes to pull and extract all the layers we saw earlier to the disk. And what this means is that the first container on the host would take this long to start. The second container to start would be quicker because now the layers are cached locally. The second image shows that the speed improvement we achieve by implementing the caching strategy I showed earlier with EC2 Image Builder, by building that custom AMI with the required layers for the app dependencies already baked into the AMI. In this example, it only took 54 seconds for the container runtime to pull that image down, but because the layers were already present on the disk, it only had to check the image metadata and create and start the pod. So we've looked at how we could reduce the launch time for a Windows container or pod, and what about improving the startup time for the worker node, or in the case of Amazon ECS, the container instance? Some of you may be familiar with sysprep for Windows, but if you're not, Windows was designed in such a way that every machine on the network must be unique. And this is achieved by assigning a security identifier, or what we call a SID, to the machine. But say you want to clone that machine to redeploy the image on another one, you have to run sysprep first to remove the security identifier. Then, when you boot the new EC2 instance with that cloned image, you need to rerun sysprep to add the SID back again, and this process takes a long time. In this example, the EKS node booted up with a custom, sorry. In this example, the EC2 worker node was booted up with a custom AMI, but we're not using fast launch in this one. At the top, in the blue box, it says the launch time, and it booted up at 2:30 a.m. and 42 seconds. And at the bottom, in the EC2 system log, it shows that the sysprep process finished 6 minutes later. So now we have a situation where you've made the effort to create a custom EKS or ECS optimized AMI to reduce the container startup time, but the host is taking so long to launch, and this could be a problem. Don't forget that this is just the time it took to start the EC2 instance. We haven't factored in yet how long it would take to join the EKS cluster or how long it would take to pull and start the container image as well. But if you enable fast launch for the same AMI, and I promise I'll dig into the details soon, it shows that it only took 1 minute and 50 seconds for the sysprep process to finish. The reason for this improvement is that the fast launch process has already run sysprep. It saved it to a snapshot, and then it used the snapshot to boot the Windows EC2 instance. Customers can enable fast launch through either the AWS console or the AWS CLI. And what you need to do is factor in how many Windows EC2 instances you think you'll need per hour. So how many you think you'll boot per hour based on that image. And on the back end, what we're going to do is we're going to launch a set of Amazon EC2 T-Series instances in your account. It's going to run the sysprep process for that AMI. It's going to save the output to a snapshot in an S3 bucket. And then every time you boot a new Windows EC2 instance, it's going to retrieve one of those snapshots and use it to boot the instance instead, which dramatically reduces the startup time, as you see here. So what we've demonstrated here is that whilst Windows containers can be slower to start than their equivalent Linux ones, there are a number of effective strategies we can use to reduce the startup time for both the containers and the underlying hosts. You had 100 other choices of places to be tonight, and you chose to be here, so we thank you very much. We hope the session was useful, and we'd love to invite any questions you may have.